Hi, my name is Gene Kim, and I'm delighted to be here at the Sprint event for the next 3 days. I've been studying high-performing technology organizations since 1999. That's a journey that started back when I was a CTO and founder of a company called Tripwire in the information security and compliance space. And so our goal was to study these amazing organizations that had the best project due date performance in development, best operational stability and reliability in ops, as well as the best posture of security and compliance. And so we wanted to understand, how did these amazing organizations make their good to great transformation so that other organizations could replicate those amazing outcomes. And so you can imagine, in a 20-year journey like that, there are many surprises. But by far, the biggest surprise to me was how it took me in the middle of the DevOps movement, which I think is urgent and important. The last time we've seen any industry being disrupted to the extent that our industry is being disrupted today was likely manufacturing, when it was revolutionized through the application of the lean principles. And I think that's exactly what DevOps is. You take those same lean principles, apply them to the technology value stream that we work in every day, and you end up with these emergent patterns that allow organizations to do hundreds or even hundreds of thousands of deployments per day while preserving world-class reliability, security, and stability. So the Phoenix project came out in 2013, and after that we wrote the DevOps handbook. And here's a definition of DevOps that we used. It is the architectural practices, technical practices, and cultural norms that allow us to increase our ability to deliver applications and services quickly and safely. That enables rapid experimentation and innovation and the fastest possible delivery of value to our customers while ensuring world-class security, reliability, and stability. And so why do we care about that? It's so that we can win in the marketplace. So as much as I love that definition, because I haven't actually said what DevOps is, instead I've described all those outcomes that we aspire to. But there's a definition that I like even more than that, and it doesn't come from me. It comes from a friend of mine, John Smart. And when he was leading the Better Ways of Working at Barclays, which was founded in the year 1634, his definition that he used was this: it's better value, sooner, safer, and happier. I love it for so many reasons. One, it's shorter. Two, it is entirely as accurate as the definition that I gave you. And three, it's so hard to object to, because who wants worse value later, more dangerously, with more misery, right? So the fact that it is an aspiration that we can all get behind. And so what I've learned is that there are still some problems that remain, such as there is still this absence of understanding of all the invisible structures required to truly enable and unleash developer productivity. There's this orthogonal problem to DevOps that needs attention. So DevOps really pointed out that how difficult it was to get code to where it needed to go, which is in production, so that customers could get value. There's this other problem that exists, which is that data is often locked in systems of records and data warehouses, and it needs to get to the hands of developers and everyone in our businesses so they can make better decisions. But it takes weeks, months, or even quarters for it to get there. And that every time that we change a report, we might break 1,000 other reports. So it is too fraught with error. There's often strong opposition to support new ways of working, and often there's ambiguity in terms of what we need from our leaders to support this kind of transformation. And so in the Unicorn project, we use the 5 ideals. So in the Phoenix project, we had the 3 ways, the 4 types of work. The 5 ideals are meant to highlight 5 areas that I think are so important. One is locality and simplicity. The second is what I think the outcomes are: focus, flow, and joy. The third ideal is improvement of daily work. The fourth ideal is psychological safety. And the fifth ideal is customer focus. So I'll go and describe for each one of these 5 ideals what ideal looks like, and what the not ideals that so many of us are stuck in. But before I do that, I really want to talk about the value that DevOps creates. And so much of this was highlighted in the book Accelerate that I co-wrote with Dr. Nicole Forsgren and Jez Humble. And this is based on the State of DevOps report. So since 2013, over 6 years, we benchmarked over 35,000 respondents, really trying to understand what does high performance look like and what are the behaviors that lead to high performance. And what we found for 6 years in a row is that high performers exist, and they massively outperform the non-high performing peers. As measured by what? We know that high performers are deploying more frequently. The high performers are deploying multiple times a day, so 2 orders of magnitude faster than their peers. More importantly, they have much lower deployment lead times. They can go from a change being put into version control, through integration, through testing, through deployment, so that customers are getting value. So that's 2 orders of magnitude more faster than the peers. But it's not just about agility, it's about the outcomes as well. When high performers do a production deployment, they're 7 times more likely to have it succeed without causing a 7 outage, a service impairment, a security breach, or a compliance failure. But when something goes wrong, which Murphy's Law guarantees, high performers can fix those issues in 1 hour or less. In other words, the mean time to restore service is 1 hour or less, 3 orders of magnitude more quickly than their peers. So what we found over 6 years is that they are more agile and they're also more reliable. And that's something that we've found year over year. We, over the years, looked at other outcome measures like security. We found that high performers were spending only 1/2 the amount of time remediating security issues because they were integrating security objectives into everyone's daily work. But even more important than these measures was something around organizational performance. We found that high performers also were twice as likely to exceed profitability, market share, and productivity goals. And for not-for-profits, same multiple. They were twice as likely to achieve organizational and mission goals, regardless of how they chose to measure it, whether it was customer satisfaction, quality, or quantity. And so the lesson is this: if mission achievement is reliant upon technology work, DevOps principles and patterns help with the achievement of those objectives. Other markers of organizational performance. Employees are twice as likely in high performers to recommend their organizations as a great place to work to their colleagues. And so the employee net promoter score is, there's a great deal of literature out there that shows its correlation to organizational growth and profitability. So what do all these numbers mean to me? It starts to paint a picture of what the opposite of technical debt is to what degree can we safely, quickly, reliably, and securely achieve all the goals, dreams, and aspirations of the organizations that we serve. So I mentioned the 5 ideals. Let's go to ideal number 1. So locality and simplicity. It really says to what degree are teams able to independently create value, to be able to develop, test, and deploy value to our customers that they want. So one of the biggest surprises for me was in the 2017 State of DevOps report, and it was around architecture. And this is such a surprise because 20 years ago, we were all trained that architectures could be ignored because they didn't impact how daily work was performed. And that is definitely, well, if that were ever the case, that's certainly not the case now, because what we found is that architecture is one of the top predictors of performance, even more than continuous integration and delivery. As measured by what? So to what degree can we make large-scale changes to our parts of the system without permission from anyone outside of our team? To what degree can we complete our work within the team without a lot of fine-grained communication coordination with people outside of our team? To what degree can we deploy and release our service on demand, independent of other services we depend upon? To what degree can we test on demand without using an integrated test environment? So all too often, we need to test in these environments that are never available. We always have to wait in line for months, and no one ever cleans them up, which actually jeopardizes the testing objective. So this is a point of coupling for us and the rest of the organization. And so if all those things are true, then we should be able to do deployments during normal business hours with negligible downtime. And so this is, again, one of the top predictors of performance. So we can boil it down to a measure. So in the Phoenix project, if there was one metric that measured the Phoenix project, it was the bus factor. In other words, how many people need to be hit by a bus before the project, service, or organization is in grave jeopardy. In the Phoenix project, the bus factor was 1. It was Brent, right? If Brent got hit by a bus, no outage could be fixed, no major piece of work could be completed without Brent. And so clearly we want a bus factor larger than 1. We need it. We don't want to be reliant on one person. We want to be reliant upon a team, or better yet, a team of teams. In the unicorn project, the first ideal could be measured by the lunch factor. In other words, to get something important done, how many people do we need to take out to lunch? Is it the Amazonian ideal of the 2-pizza team, where every two-pizza team can independently create value for our customers without being reliant upon other people? Or do we need to feed everyone in the building? So think about a major complex deployment where we might have to feed 200 people or even 300 people, right? Because responsibility is scattered across so many different silos. Or do we have to take 43 different people out to lunch because we need something from them? And they may never have heard of us. And any one of those 43 people, if they say no, we can't do what needs to get done. So ideal is that to get something done, we can implement what we need to by looking at one file, one module, one application, one container, and so forth. Not ideal is to make our needed change, we have to understand and change all the files, all the modules, all the applications, all the containers, right? So we've lost that locality, and again, we're coupled to everybody else. Ideal is when our changes can not only be implemented in isolation, but they can be tested in isolation, right? Isolated from all the other components. So in functional programming, we call that the notion of composability. Not ideal is in order to test the system, it has to be done in the presence of every other component. Again, drawing us back to that integrated test environment. In the ideal, every team not only has the expertise and capability to do what customers need us to do, but we also have the authority. Not ideal is that to make any decision, we have to go up to, over to, and then down to. So visually depicted, we have to go up to, over to, and down to. So friends of mine, they say this is the square. And so this is actually the good path. The bad path is we have to do the return path to allow two engineers to work together to do what the customer needs. One of the best books on this is the book Team of Teams by General Stanley Crystal, Chris Fussell, and Dave Silverman. And it is an amazing book that tells the story in a greater context, specifically around the Joint Special Forces Task Force in Iraq in 2004, where they were battling a far smaller, but far more nimbler adversary, specifically Al-Qaeda in Iraq. And they tell this amazing journey of how they're able to speed up decision-making, push decision-making down to the edge, bring authority to the information as opposed to information to the authority. I recommend this book to anyone that cares about this because there's so many lessons in that book. So first ideal is locality and simplicity. Second ideal is focus, flow, and joy. And so much of this was informed by me learning Clojure, the Clojure functional programming language that runs on the JVM or in JavaScript. It was the hardest thing I've ever learned, but it changed my life. It reintroduced the joy of programming back into my life. And so for 20 years, I primarily self-identified as an ops person. This was despite getting my graduate degree in compiler design in 1993. But I always gravitated towards ops because it was my observation that was ops where all the saves were made. It was ops who saved us from terrible developers who didn't care about quality. It was ops that protected our application and data because it certainly wasn't information security. And yet, Clojure changed my mind. It showed me how fun development is and how you can build so many great things with so little effort these days. And so the French philosopher Claude Lévi-Strauss would say of certain tools, is it a good tool to think with? And I think functional programming and Clojure taught me and gave me better tools to think with, like immutability. And so immutability is core to many languages like Haskell, like Clojure, ReasonML, PureScript, but it's not just programming languages. You find immutability showing up in infrastructure and operation as well because it helps us reason about and control complexity. And you see this in Docker. So Docker is all about immutability. If you want a lasting change to a container, you have to make a new one, right? Because local changes will get wiped out the next time you run that container. Kubernetes takes that to not just a component level, but the system or system of systems level. In fact, Kubernetes sidecars, which I found so baffling for so many years, suddenly made sense. The idea is that you can change a container without actually changing the application container. When you say something like Kafka or PubSub or message queues, that is often the desire of to create an immutable data model. And Git and version control in general is all about immutability. And that's why we get yelled at when we rewrite the commit history. So immutability is a better tool to think with, and it enables this ideal where our best time and energy is focused on solving the business problem and that we're having fun. Not ideal is that all our time and energy is spent solving problems that we don't even want to solve, like writing Kubernetes deployment YAML files or figuring out how to escape file names inside of makefiles or bash or writing ingress rules, right? And so what's so interesting to me is that there are a whole category of activities I used to enjoy doing a decade or two ago that I now detest doing. I hate doing anything outside of my application. I hate connecting anything to anything else because it always takes me a week. I barely know how to write CIDR blocks anymore. I hate updating dependencies. Secrets management. I'm the person who checks in secrets into the source code repos, often necessitating creating a whole new repo. Bash, YAML, patching. I can't get Kubernetes deployment files right on my first time. I can't understand my cloud costs are so high. And so I'm not intending to diminish these activities. In fact, these are important, and especially around security, right? Arguably, that is as important as the functionality that we as developers create. But I just don't like doing it anymore. And I think what rescues us is developer platforms. There's so many things we can do now through platforms because we are taking things like monitoring, deployment, environment creation, security scans, configuring firewalls, ingress and proxy, orchestration. All those things are now showing up in the platforms we use. So we can do them self-service, on demand, with a sense of immediacy and fast feedback, which I believe create the conditions for us to get a sense of focus and flow and even joy in our work. So I will make this claim that there has never been a better time to be in infrastructure and operations than now. And I would also add in security because we need all that expertise, not in their heads, but in the platforms they use, they create for us to use. And so to talk about flow, I would refer you to Dr. Mihaly Csikszentmihalyi. He's a cognitive psychologist, and he gave one of the best TED Talks of all time with the title of Flow, The Secret to Happiness. He describes a state of flow as being the sense of the feeling that we feel when we are so immersed in the work that we love, that we lose track of time, and maybe even sense of self, that transcendental experience that we have when we are doing the work that we love. And platforms, by taking away the things that we don't care about, allows us to focus, be productive, and enjoy our work. I keep screenshots of things that I don't ever want to Google for, like Java string decided write CIDR blocks and Java date times, right? Important, but not what I woke up in the morning to solve. So ideal is when we can do our work and implement what we need to and test the feature on our laptop and learn whether it works within seconds. Not ideal is that the only way we can determine whether this will work in production is by pushing the production or waiting minutes, hours, days, or even weeks. So ideal number one is locality and simplicity. Second ideal is what the outcomes are: focus, flow, and joy. And the third ideal is improvement of daily work. So this showed up in the Phoenix project. And what it stated that improvement of daily work is even more important than daily work itself. So not ideal is twatty, the way we've always done it, right? So why change? That's not so good. What we want is the ideal, MTBTT, or better yet, make tomorrow better than today. That comes from Google SRE principle number 2. I think it's almost poetic, right? We should all be striving to make tomorrow better than today. So what is not ideal? Probably the best example of this was the General Motors Fremont manufacturing plant before it turned into the site of the joint venture with Toyota and before it turned into a Tesla plant. This plant was notorious because for decades, it was not only the worst manufacturing plant in North America, but around the globe. There were so many instances because there were no effective procedures in place to detect problems through the assembly process, and because there were no explicit procedures on what to do when problems were found. There were so many instances of engines being put in backwards, cars missing steering wheels or tires, cars having to be towed off the assembly line because they wouldn't start. So this is clearly not ideal. What instead do we want? We want to create a system with as much feedback embedded into it, with from as many areas in the system as possible, where we can get feedback sooner, faster, cheaper, with as much clarity between cause and effect. And the reason for this is that the more assumptions we can invalidate, the more we learn. And the more we learn, the more that we can outcompete our competitors in the marketplace. So in 2011, I spent a week at the University of Michigan learning about the Toyota production system. And I got to learn about one of the most famous tools in the Lean toolkit, the Toyota Andon cord. So this, of course, is what is on top of every work center in a Toyota plant, where if something goes wrong, we pull the cord. So if I manufacture a defective part, I pull the cord. If I get a defective part from someone else, I pull the cord. If I have no parts to work on, I pull the cord. I even pull the cord when the work takes longer than documented. So if it was supposed to take 55 seconds and it took 1:20, I pull the cord. So what happens when I pull the cord. If I can't resolve the issue in 55 seconds, the entire assembly line stops. So I knew that going into the training. What I didn't know was how many andon cord pulls per day there was in a Toyota plant. So just in your head, think how many andon cord pulls are there in a typical Toyota plant per day? And the answer is this, 3,500 pulls per day. And so my first reaction was, yeah, these people have no idea what they're doing, right? These guys are idiots, right? So why would I believe that? It's because we're taking a local disturbance and turning that into a global disturbance, which is very much the opposite of the way I was trained. I solve areas in my area of control before it causes a local, a greater disturbance. So why do they do this? Why do they do something so disruptive so frequently? There are two answers they give, which I find very viscerally important. One is, if we don't put in a systemic fix then and there, technical debt accrues downstream or becomes far more expensive or maybe even impossible to fix. So that's interesting, but not as interesting as the second response. If we don't put in a systemic fix then and there, we're going to have the same problem 55 seconds later. And so that's the notion of a daily workaround. And so daily workarounds exist in our work as well, but because our work takes longer than 55 seconds, it is not as visible, but it is absolutely just as destructive. So again, that gets to my point that greatness is never free, right? We must create greatness, and we must do that through the paying down of technical debt. So let me tell you a story of how we create technical debt, where it comes from, and what we must do to eliminate it. And I'm going to tell the story only using up and down arrows. A friend once told me, when dealing with senior executives, stick with only small numbers and primary colors. But what I found in my journey was that often that's not sufficient. Stick with something even simpler, up and down. So here we go. Imagine a situation where we had to push to get to market. And so this is where the focus is all about features, either to be first to market, or when we're not first, we need to get into the market because we're last. And so when that happens, this is when we start cutting corners. We create technical debt, we build up risks. What that does is drive down quality. When quality goes down, the number of defects go up. So the story doesn't end there. If you go forward in time, what ends up happening is that the number of features that we can ship go down, right? Because the amount of time we're spending on defects go up, even to the point where our daily work is dominated by fixing defects, defects that escape into production. This is when site reliability tanks. This is when we go slower and slower. Customers leave, morale plunges, and engineers now leave because everything that used to be easy is now so hard. A friend tweeted this out at me. He said, exactly. Case in point, in 2015, a certain reference feature would take 15 to 30 days to implement. 3 years later, same class of feature now takes 10 times longer. And so if you've ever felt that this has happened to you, it's because it's true. And this happens despite adding more developers. So here is my favorite example of the risk of technical debt, and that is Nokia. So I mentioned Team of Teams. Here's the second book I would recommend to everybody, by Transforming Nokia by Risto Salasma. So he joined the Nokia board in 2008. And your first reaction is, what can we learn by someone who oversaw the decimation of 93% of the market cap of Nokia? And the answer is a lot. It is this unflinching look of his tenure at Nokia, and how they recovered afterwards. The best line is, in 2010, he described the scene when he learned from the VP of strategy that the build and test times for Symbian took 48 hours. He said when he learned that, it felt like being hit in the head with a sledgehammer, because he knew if it took 2 days for an engineer to learn whether the change worked or would have to be redone, all the hopes and dreams of that platform was an illusion, right? That it was doomed to fail. And that's actually what drove them to Windows Mobile, which didn't treat them so well either. But that was actually a better bet than staying on Symbian OS. And so Nokia didn't make it. But every organization that has gone through this has a different story, whether it's eBay, Microsoft, Google, Amazon, Twitter, LinkedIn, Etsy. They were almost all killed by technical debt as well, but they survived. So what did they all do differently? So I think the best example is Microsoft 2002. So this is right after the summer of worms, when SQL Slammer, Code Red, Nimda threatened to basically make sure that no one would use a Microsoft product because it was so prone to being taken down by external attackers. The countermeasure was so interesting. Bill Gates put out this trustworthy computing memo where they went on a security stand down. And they basically, every major product line stopped working on features. In fact, in this memo, he said, if a developer ever has to choose between working on a feature or fixing a security issue, you must always choose the security issue. And so this is what every one of those organizations did. They took feature rate down to 0 so they could pay down technical debt, so they could increase quality, so they could drive down the number of defects. Maybe not to 0, but something that was manageable on a regular ongoing basis. And what the result is that drove up developer productivity and the feature velocity orders of magnitude where they were before. And it's not just the CEOs. This comes from product owners as well. This is Marty Kagan. He's trained generations of product owners on how to build products that customers love. And his advice after going through a traumatic experience at eBay in the early 2000s as their VP of product management is that you must pay a 20% tax. You must take 20% of all DevOps cycles off the table to pay down technical debt. Because if you don't pay that 20% tax, you will invariably pay 100% tax. He did not ship a major feature at eBay for 2 years during his tenure at eBay. And so the only way to avoid that is to pay down technical debt as you go. So learning here is that in the ideal, 3 to 5% of the best engineers are working on improving developer productivity. Google has over 1,500 developers working on dev productivity, $1 billion of annual spend a year. Microsoft, even more than that. Not ideal. In most organizations, the only people working on dev productivity and platforms are summer interns and people not good enough to work on features. So in a wonderful story of karmic continuance, Satya Nadella, current CEO of Microsoft, says, in a town hall meeting last year, he said, if a developer ever has to choose between working on a feature or working on dev productivity, always choose dev productivity, because this is how we use compounding interest to our favor, as opposed to technical debt, which is very much to our detriment, or maybe to our destruction. So first ideal was locality and simplicity. Second ideal was focus, flow, and joy. Third ideal is improvement of daily work. Fourth ideal is psychological safety. So this we found in the State of DevOps report is that culture was one of the top predictors of performance. This is the Westrom organizational typology model. Dr. Ron Westrom in 2004 studied healthcare organizations, and he found that organizations with the best patient outcomes were highly correlated with very interesting cultural metrics. Those with the worst patient outcomes had these characteristics. We hide information. We shoot messengers who tell us bad news. We discourage bridging between teams. We cover up failures and new ideas are crushed. Whereas in the best patient outcomes, the organization exhibited these characteristics. We actively seek information. We train messengers to tell bad news, like in blameless postmortems. We bridge between teams, responsibilities are shared, because everyone knows that InfoSec is not just InfoSec's job, just like uptime is not just Ops' job, it is everybody's job. Failure causes a genuine sense of inquiry, and new ideas are welcomed. It was so fun researching the Unicorn Project because it made me revisit the work of Project Aristotle and Oxygen at Google. They spent years trying to learn what made the best teams the best. And year after year, the top factor was psychological safety, as measured by to what degree do people on a team feel safe to take risks, to say what they really think, without fear of ridicule or being made to feel embarrassed or being punished. That had a higher predictor of performance than dependability, structure and clarity, the meaning of work, or the impact of work. So in the DevOps community, we love talking about blameless postmortems or the exciting nature of chaos monkeys and game days where we deliberately inject faults into the production environment. But none of this is possible without psychological safety. So first ideal, locality and simplicity. Second ideal, focus, flow, and joy. Third ideal is improvement of daily work. And the fourth ideal is psychological safety. The fifth ideal is customer focus. Probably the best way to share what an aha moment this was when I got to visit the CEO of CompuWare for a day. So they're a famously resurgent mainframe vendor. And so I took a friend with, and I noticed while walking to the building that the first item up on the agenda was a data center tour. And I was immediately embarrassed. I was trying to explain to my friend, McKirsten, I'm sorry, I have no idea why we're getting a data center tour. I don't know what we'll learn by looking at their halon extinguishers. And yet, what I saw changed my life. It was like one of the biggest aha moments in my career, because this is what I saw. Yes, you walk into a data center, but it was mainly empty. Yes, there were 2Z mainframes because they're a mainframe software vendor, but there was over 50,000 square feet of empty space. Instead, if you look on the floor, there's these green outlines, like in a murder scene of where the server racks used to be. And in the middle of each one of those outlines is a tombstone describing the application and the business process that used to be there, as well as how much money they saved by getting rid of it, moving it to a SaaS vendor. So EMEA financials, on-prem email, help desk, client backup, all these things gone. And so why is this important? Oh, and there's also this little sign that says over 14 tons of obsolete equipment removed and recycled, sent to a better place. So why is this important? Dr. Geoffrey Moore has this amazing book called Zone to Win, and he describes the notion of core versus context. Core is our core competencies, the things that create lasting, durable business advantage that customers are willing to pay us for. And context is everything else. So it might be mission critical, like payroll or like HR systems, like our ERP system, but customers don't pay us extra money just because we have great payroll services to our employees. So it's mission critical, but do not create lasting business advantage. So that CompuWare data center slide, what it shows is that by getting rid of all that stuff, they were able to reallocate $8 million from context and put it into core by investing into R&D, something that customers absolutely pay for. And so not ideal is when functional silo managers prioritize their silo goals over the grandest business goals. Ideal instead is when everybody, not just functional silo managers, but when we can unflinchingly look at the work we are doing in a given day and ask, is this creating genuine, lasting, durable business advantage? Is it part of core? And if it's not, it's part of context. And maybe we should start asking whether we should be doing it at all or moving that to a vendor where it is their core competency and that is what we pay for. So why do I think this is important? We are now entering the age of software and data where all of these things matter regardless of what industry we're in. But more importantly is this quote, the world is changing very fast. Big will not beat small anymore. Instead, it is fast beating the slow. And so in an age where we all need to be fast to survive and win in the marketplace, speed matters more than anything. And so the 5 ideals are really intended to frame things that we can do to help us work faster, safer, happier, so that we can win in the marketplace. It has been such a pleasure to be a part of Sprint Day 1, and I look forward to spending the next 2 days with you, especially the amazing Day 3 of the hackathon, which I am so looking forward to. So if you're interested in any of the material, just email the NGINX team, and they can make this presentation available to you. And if you're interested in anything else, such as excerpts of and videos from the DevOps Enterprise Summit and other books I've written, just email realgenekim@sendyourslides.com, subject line DevOps, and you will get an automated response in the next minute or two. Thank you so much. I hope you've had a great day 1, and I look forward to interacting with you over the next 2 days. Thank you so much.